The quest for eternal youth is a tale as old as time itself. Myths and legends are full of stories about fountains of youth and magical elixirs. While these remain firmly in the realm of fantasy, recent scientific advancements have brought us closer than ever to understanding the aging process. What's even more exciting is that we are now on the cusp of potentially manipulating this process to extend our health span and lifespan significantly. For centuries, aging was considered an inevitable consequence of life, a slow and steady decline we were powerless to prevent. However, this fatalistic view is rapidly changing. Scientists now understand that aging is a complex process influenced by a multitude of factors, many of which we can potentially control. We are beginning to unravel the intricate mechanisms that govern how our cells and tissues age. Two groundbreaking areas of research, in particular, hold immense promise: chemical reprogramming for cellular rejuvenation and the selective elimination of senescent cells. These cutting-edge technologies target aging at its very core, offering the potential not just to slow down the clock, but to potentially reverse it. Imagine a future where age is no longer a limiting factor, where we live longer, healthier lives, free from the diseases and disabilities often associated with growing old. This is the future that anti-aging research is striving towards, and the breakthroughs of 2024 have brought us tantalizingly close to making this dream a reality. Let's delve deeper into these exciting advancements and explore how they could reshape our understanding of aging and transform the future of human health. Imagine being able to turn back the clock on your cells, resetting them to a younger, healthier state. This is the revolutionary idea behind chemical reprogramming, a novel approach to anti-aging that has taken the scientific community by storm. In essence, it involves using a cocktail of molecules to reprogram cells, erasing the damage accumulated over a lifetime and restoring them to a more youthful state. This groundbreaking technology stems from the Nobel Prize-winning discovery of induced pluripotent stem cells, iPSCs. Scientists found that mature, specialized cells could be reprogrammed back into an embryonic-like state, capable of becoming any cell type in the body. Building on this, researchers are now exploring ways to use similar techniques to rejuvenate cells without completely erasing their identity. The process involves introducing a specific combination of molecules, often transcription factors, into aging cells. These factors act like genetic switches, turning on genes associated with youthfulness and turning off those linked to aging. This chemical reprogramming can potentially reverse many hallmarks of aging, such as DNA damage, cellular senescence, and mitochondrial dysfunction. While still in its early stages, chemical reprogramming has shown remarkable results in laboratory settings. Studies have demonstrated its ability to reverse age-related changes in cells, improve tissue function, and even extend lifespan in animal models. The implications of this technology are far-reaching, potentially offering a way to treat a wide range of age-related diseases and extend human health span. As we age, our bodies accumulate senescent cells, dysfunctional cells that have stopped dividing but haven't died off like they should. These cellular zombies, instead of quietly exiting the stage, linger in our tissues and organs, secreting harmful molecules that contribute to inflammation and damage surrounding healthy cells. Imagine a neighborhood where abandoned houses, instead of being demolished, are left to decay, attracting pests and negatively impacting the surrounding properties. That's what senescent cells do to our bodies. This accumulation of senescent cells is now recognized as a key driver of the aging process and a major contributor to age-related diseases, including cancer, heart disease, and Alzheimer's disease. The good news is that scientists have developed a new class of drugs known as senolytics, specifically designed to eliminate these troublesome cells. Senolytics work by targeting the survival pathways that senescent cells rely on. Essentially, they push these cellular zombies over the edge, triggering their natural death cycle and removing them from the body. This targeted removal of senescent cells has shown remarkable results in preclinical studies, improving tissue function, reducing inflammation, and extending lifespan in animal models. The development of senolytics is a major breakthrough in anti-aging research, offering a way to combat one of the root causes of aging and age-related diseases. By clearing out these cellular troublemakers, we can potentially slow down the aging process, prevent or delay the onset of age-related diseases, and live healthier lives for longer. The potential applications of chemical reprogramming are vast and incredibly exciting. Imagine a future where we could rejuvenate damaged organs, reverse age-related diseases, and even extend our lifespans. While this might sound like science fiction, the groundbreaking research in chemical reprogramming suggests that these possibilities may be closer than we think. One of the most promising areas of application is in regenerative medicine. Reprogramming cells to a younger state could revolutionize organ transplantation. Imagine being able to take a patient's own cells, rejuvenate them, and then use them to grow new, healthy organs for transplantation, eliminating the need for donors and the risk of rejection. This technology also holds immense potential for treating age-related diseases. By reprogramming cells affected by diseases like Alzheimer's, Parkinson's, or heart disease, we could potentially reverse the damage and restore them to a healthy state. This could lead to a paradigm shift in how we approach these diseases, moving away from simply managing symptoms to actually targeting the underlying causes of aging and disease. Moreover, chemical reprogramming could pave the way for extending the human lifespan. By resetting the aging clock of our cells, we could potentially slow down or even reverse the aging process, allowing us to live longer, healthier lives. While there is still much research to be done, the possibility of extending our health span and lifespan through chemical reprogramming is an incredibly exciting prospect.